Welcome to the peaceful space of sleep-friendly science, where tonight we explore the very fabric of reality, from the smallest possible thing to the vastness of the cosmos, asking if our minds can truly grasp infinity. Our journey tonight is one of scale. We will stretch our minds gently, from the familiar comfort of our own bodies to the breathtaking emptiness between the stars. There are no equations, only a quiet sense of wonder. Feel your own sense of scale begin to dissolve. Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1: The Human Yardstick. As you lie here now, feel the quiet reality of your own body. Feel its weight, its warmth, the gentle rise and fall of your breathing. Feel the boundary of your skin, the subtle line that separates the universe of you from the universe of not you. This is the first and most fundamental scale of your existence. It is scale 1:1. It is the one thing you know with an unshakable, intuitive certainty. Your mind and your body are perfectly matched to this scale. You know the length of your own arm, the reach of your own hand without ever having to think about it. Now let your awareness expand to fill the room around you. This too is a comfortable scale. You can comprehend its dimensions. You know how many steps it would take to cross from one wall to another. You can imagine reaching out and touching the ceiling. This room is a vessel, and you are perfectly sized to it. This space is knowable, tangible, and safe. Your mind possesses a beautiful and ancient measuring stick, a tool forged over millions of years of evolution. Let's call it the human yardstick. It is calibrated perfectly for this world. With this yardstick, you can measure the height of a tree, the width of a river, the distance to a far-off hill. You can hold a stone in your hand and feel its size and weight. You can look at a handful of pebbles and have an intuitive sense of whether there are 5 or 50. Your brain is a master of this domain. It is a world of things you can walk around, hold in your hand, or see in a single glance. It is the world of the human, and it is the only world our intuition was ever built to understand. Let us stretch this yardstick a little further. Think of your neighborhood, your town, your city. The scale is larger now, but still tethered to your human experience. You cannot see the whole city at once, but you can walk its streets. You can travel from one end to the other in a comprehensible amount of time. The city is a mosaic of smaller, human-sized pieces that you have stitched together in your mind to form a larger map. You can hold the idea of the city in your head, even if you cannot hold the city itself in your hands. Our human yardstick is still a useful tool, though we must now lay it down end to end many times to measure the distance. But now find a place in your mind with a vast open view. A quiet beach looking out over a calm ocean, or a high hill overlooking a wide plain. Look to the horizon. Here at this quiet edge, your human yardstick begins to fail you for the first time. Your senses, your deep and ancient intuition, tell you that you are looking at a flat line, the edge of the world. But your intellect, your reasoning mind, knows a different truth. It knows you are living on the surface of a colossal sphere, and that the horizon is not an edge at all, but simply the limit of your sight on a curved surface. This is the first gentle hint of the great problem of scale. It is the first moment where your innate feeling and your abstract knowledge begin to pull apart. Your yardstick, so perfect for measuring the things in your world, gives a profoundly misleading reading of the world itself. This is because we are creatures of the middle distance. We evolved on the surface of this planet, in a world where nothing was much bigger than a mountain, and nothing much smaller than a grain of sand. Our minds are finely tuned instruments, but they are tuned to a very specific, very narrow band of reality. We are the masters of the human scale. We are at home here. But our journey tonight is about leaving this home. It is about willingly stepping out of the well-lit, comfortable room of human perception and venturing into the two great dark infinities that lie on either side. We will journey outwards into the cosmos, where our yardstick will become so small as to be meaningless. And we will journey inwards into the atom, where the very concept of a yardstick dissolves into a shimmering cloud of pure potential. We are about to discover that the fabric of reality is woven on a loom of scales so vast and so minuscule that our minds can only touch them with the fragile fingertips of metaphor and number. Our intuition, our most trusted guide, must be left at the door. Section 2. The Sun's Neighborhood. From the familiar comfort of our home world, let us take the first tentative step outwards. Let your mind's eye lift from the horizon and gaze up at the sun. On a clear day, it feels close, a benevolent golden lamp hanging in the sky just above us. Its warmth a tangible presence on your skin. Your human yardstick, your intuition, registers it as a part of your world. But the light that warms your face now left the sun 8 minutes ago. If the sun were to suddenly vanish, you would continue to feel its warmth and see its light for a full 8 minutes, living in the gentle echo of a star that was no longer there. This is our first clue. The distance is already greater than our senses can process. Let's try to measure this distance with our familiar tools. If you were to get in a car and drive towards the sun, maintaining a steady highway speed, you would not arrive next week or next year or even in the next decade. Your journey would last for over a century and a half. Generations would be born and pass away in the car on this impossible road trip to the closest star. Our yardstick is already beginning to fray. The numbers are becoming too large, too abstract to hold. So let us try a different trick, a classic feat of the imagination. Let us shrink the entire solar system down to a scale our minds can handle. Let's take our vast blue-green planet Earth, with all its mountains and oceans, all its cities and forests, and let us shrink it in our minds until it is the size of a single grain of sand. A tiny blue fleck speck that you could hold on the tip of your finger. Now, on this new miniature scale, where is the sun? If you are holding the earth sand grain in your hand, the sun is not a lamp in the same room. It is not across the street. On this scale, the sun would be a glowing orb the size of a large grapefruit, and it would be located about a football field away from your grain of sand. Take a moment to absorb this. An entire football field of cold, empty space separates a single grain of sand from a grapefruit. This is the relationship between our world and its star. And what of the other planets, our neighbors? Where is Jupiter, the king of the solar system? In our model, Jupiter would be the size of a large chestnut or a small marble. And it would be located not a few feet from our grain of sand, but 5 football fields away from the grapefruit sun. And Saturn, with its ghostly rings, would be a beautiful smaller marble nearly 10 football fields away. They are lonely wanderers in a vast, dark arena. The image you might have from a school textbook, with the planets all nestled closely together in a neat line, is a beautiful and necessary lie. It is a lie we tell ourselves to make the solar system fit on a single page. The truth is far more stark and far more empty. The reality of our solar system is not the planets. The reality is the space between them. A profound, cold, and silent emptiness, punctuated by a few tiny lonely specks of matter. Let us push our model to its limit. Where is Neptune, the last true planet in our sun's family? It would be a speck the size of a coffee bean, located about 30 football fields away from our central grapefruit sun. Our human yardstick has not just frayed, it has snapped. We are trying to measure miles with a tool meant for inches. And our solar system doesn't even end there. Beyond the orbit of Neptune lies a vast, scattered realm of icy bodies. And surrounding it all like a great ghostly sphere, is the Oort cloud, the deep frozen reservoir of comets. In our scale model, where the Earth is a grain of sand, this ghostly sphere would begin at a distance of several hundred miles, and it would extend outwards for thousands of miles. The entire solar system in this human scale model would be a tiny grapefruit and a few scattered specks of dust and pebbles, lost inside a volume of space larger than a major city. Our neighborhood is the kingdom of the void. We are not residents of a crowded street. We are the inhabitants of a single lonely grain of sand, adrift in an ocean of emptiness so vast that we have not yet even begun to comprehend its shores. Section 3. A City of Stardust. Our solar system, which once seemed a vast and unknowable place, now feels like a single lonely household in a great dark country. Our sun a grapefruit, our earth a grain of sand, and the space around us an immense and silent void. Now we must take the next and perhaps the most difficult step in our outward journey. We must try to comprehend the scale of the city our lonely household belongs to. We must try to imagine the Milky Way galaxy. Let us abandon our last model. A model where the sun is a grapefruit is already too unwieldy to be useful. We need a new act of radical shrinking. Let us perform a new feat of the imagination. Let's take our entire solar system, the sun, all the planets, the vast, ghostly sphere of the Oort cloud, everything, and let's shrink it all down until it is the size of a single grain of sugar. A tiny crystalline speck that you could lose in the bottom of a teacup. You are holding this single grain of sugar in the palm of your hand. It contains our sun, our earth, everything you have ever known. Now, where is the next grain of sugar? Where is the nearest star to our own Proxima Centauri? The answer is breathtaking. On this new scale, the next grain of sugar is over 4 miles away. Let this sink into the quiet of your mind. 4 miles of absolute, crushing emptiness between 2 single grains of sugar. This is the reality of the space between the stars. And this is just our closest neighbor. Now let us imagine the city itself. The Milky Way galaxy. It is a vast spinning spiral-shaped city of stardust. A celestial metropolis of which our sun is just one single unremarkable citizen. How many stars are in this city? How many grains of sugar does it contain? The numbers our astronomers give us are so large they are just abstract symbols. 200 billion. 400 billion. What does that even mean? Let us try to feel it instead. Imagine you are standing on a vast dark beach at night. And on this beach there is sand. A lot of sand. Now scoop up a double handful of this dark sand. Feel its weight, the coolness of the individual grains running through your fingers. The number of grains of sand you are holding in your 2 hands is roughly equal to the number of stars in our Milky Way galaxy. Every single one of those grains is a sun. Many, perhaps most of them, are just like our own sun, the center of their own families of planets, their own solar systems, their own tiny specks of sugar lost in the 4-mile void. In your hands, you are holding 200 billion solar systems. You are holding a galaxy. Now, where is our sun in this handful of galactic sand? Where is our home? We are not at the center. We are not in a place of any special importance. We are a single anonymous grain about 2/3 of the way out from the brilliant, crowded center towards the city's quiet edge. We are a resident of the galactic suburbs. And how large is this city of stardust? How wide is this handful of sand? If you were to shine a flashlight from one edge of the galaxy to the other, that beam of light, traveling at the fastest speed the universe allows, would take 100,000 years to make the journey. 100,000 years for light to cross our own city. The light from the stars on the far side of our galaxy that you might see in a telescope tonight began its journey when our human ancestors were first venturing out of Africa, when mammoths still roamed the earth. You are not seeing the galaxy as it is now. You are looking at a time capsule. You are seeing 100,000-year-old memory. Our human yardstick is not just broken now. It has been ground into a fine, imperceptible dust, lost among the billions of other grains of sand in our hand. The scale of our own home galaxy defies our intuition, our language, our very ability to form a coherent mental picture. We live inside a structure so vast that we can never see it all, so ancient that we can never know its present. We are a single thought, a single breath, inside a mind of stars so grand it can never know we are here. Section 4. The Universal Tapestry. You are holding the galaxy in your hands. A double handful of dark sand, 200 billion grains, each one a sun, separated by an unimaginable void. Our home. And it feels like the ultimate scale, the final mind-breaking frontier of comprehension. But now we must summon our courage for one last outward step. We must see that our handful of sand is not the only one on the beach. The beach itself is the universe. And it is a beach that stretches on, perhaps forever. Let us once again perform a necessary act of mental violence, a shrinking so profound it almost feels absurd. Let's take our entire Milky Way galaxy, our 100,000 light-year wide city of 200 billion suns, and let's shrink it all down until it is the size of a single small coin. A penny. You are holding this penny in your hand. It contains everything we have just struggled to imagine. Every star, every planet, every nebula. Our sun is a single invisible atom within this copper coin. Now, with this new galactic scale in mind, let's ask the question again. Where is the next coin? The nearest major galaxy to our own is Andromeda. It is a slightly larger, more majestic spiral city of stars than ours, perhaps containing 1 trillion suns. On our new scale, where our galaxy is a single penny, Andromeda is a slightly larger coin, and it is located about 6 feet away from you. Take a moment to truly feel this. 2 vast, magnificent cities of stardust, each containing billions of suns, reduced to 2 small coins separated by the length of a human body. Between them lies 2.5 million light-years of cold, dark intergalactic space. A void so profound it makes the space between the stars seem crowded. If you were to set out from our penny galaxy in a spaceship traveling at the speed of light, your journey to the Andromeda coin would take 2.5 million years. And our galaxy and Andromeda are not alone. They are the 2 largest members of a small local cosmic neighborhood we call the local group. This is a small cluster of about 50 galaxies, most of them tiny faint dwarf galaxies. In our model, the local group would be a scattering of coins and dust motes in a space about the size of a large living room. This living room, our local group, is our true cosmic home. But it is just one single room in a house of unimaginable size. The local group is itself a part of a much, much larger structure. A supercluster of galaxies we have named Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea contains 100,000 galaxies, 100,000 coins, not scattered randomly like dust, but arranged in a structure of breathtaking beauty. When we zoom out to this scale, we finally begin to see the true texture of the universe. It is not a uniform soup of galaxies. It is a web, a vast, intricate, and luminous tapestry. The galaxies are not the threads of this tapestry. They are just the tiny glittering beads sewn onto the threads. The threads themselves are immense, glowing filaments of dark matter and intergalactic gas, stretching for hundreds of millions of light years. And connecting these filaments are the great, dense knots where thousands of galaxies are clustered together, like grand celestial cities. And what lies between the filaments of this cosmic web? The voids. Immense, nearly empty bubbles of almost perfect nothingness, hundreds of millions of light years across. Regions of space so empty that if our own galaxy were inside one, we would look out into the night sky and see almost nothing but blackness. We would be profoundly and utterly alone. This is the largest scale we can currently perceive. A web of light and darkness, of matter and void, stretching for billions of light years in every direction. And every point of light in this web is a galaxy. A penny in our model, an island universe containing billions of stars and worlds. And as far as our most powerful telescopes can see, this web continues in all directions with no discernible edge, no center, and no end. Our human yardstick is a forgotten memory. Our minds, built to comprehend the path to the river, are now adrift in an ocean of scale so vast that to even speak of it is an act of poetry, not of comprehension. We are not just a grain of sand on a beach. We are a single atom within a single grain of sand, on a beach that may have no shore. Section 5. The Inner Universe. We have journeyed outwards, to the very edge of imagination, to a cosmic scale of such breathtaking vastness that it has dissolved our sense of self into a mere speck of stardust. It is a journey that can leave you feeling small, insignificant, lost in an ocean of infinities. So now let us change direction. Let us turn our gaze away from the heavens and begin the second great journey. Let us travel inwards. For the universe is not just vast on the outside. It is equally vast, equally complex, and equally mysterious on the inside. Our journey begins where our first one started, with your own body. Scale 1:1. But now let us choose a single point on that body, the tip of your finger. Rest your awareness there. Feel solid, a single unified thing. Now let us begin our inward descent. Imagine you have a microscope of impossible power. As you zoom in on the skin of your fingertip, the smooth surface resolves into a landscape of ridges and valleys, the familiar pattern of your fingerprint. Zoom in further, and this landscape dissolves. You are now looking at a mosaic of individual skin cells, packed together like cobblestones on an ancient street. Each one is a tiny walled city, a living entity in its own right. Your body is not a single thing. It is a cooperative, a federation of some 30 trillion of these cellular cities. Let us choose one of these cities, a single cell, and pass through its outer wall, its membrane. You are now floating inside a world more complex, more crowded, and more beautiful than any human metropolis. This is not empty space. This is the cytoplasm, a thick jelly-like sea, teeming with activity. All around you are structures of exquisite design and purpose. You see the mitochondria, the city's power plants shaped like tiny beans, steadily burning fuel to power every activity. You see the ribosomes, the city's factories' great protein-building machines, churning out the materials needed for construction and repair. You see long, elegant filaments of the cytoskeleton, the city's internal scaffolding, providing structure and acting as a highway system, along which molecular cargo is transported. The sheer density of it is overwhelming. In this single microscopic cell, there are billions of individual protein molecules, each one a complex folded machine performing a specific task. They are the city's workers, its messengers, its defenders, its construction crews. They are all moving, all interacting, a constant, perfectly choreographed dance of impossible complexity. The number of individual molecular machines inside this one cell is greater than the number of people living on the entire planet Earth. And at the heart of this teeming metropolis lies the inner sanctum, the great library and command center, the nucleus. Let us pass through its protective double membrane. Here, in this quiet, protected space, lies the blueprint for the entire city, and for the entire federation of 30 trillion cities that is you. Here are your chromosomes, the most miraculous pieces of origami in the universe. Let us zoom in on one. You see a long tangled thread. As you get closer, you see it is a single immense molecule, a strand of DNA coiled and supercoiled upon itself with breathtaking efficiency. If you were to take the DNA from this one single cell and unspool it, stretching it out into a straight line, this impossibly thin thread would be about 6 feet long. 6 feet of information-rich code, packed into a space 1,000 times smaller than the eye of a needle. If you were to take the DNA from all the cells in your body and lay it end to end, that single ghostly thread would stretch from the earth to the sun and back again, not just once but hundreds of times. You are not just a body. You are a universe of inner worlds. The complexity contained within a single one of your cells rivals the complexity of a star-forming nebula. The empty space we found between the stars is, on this inner journey, replaced by a teeming, vibrant, and purposeful density. You are a walking, talking galaxy cluster of living cells. The vastness is not just out there. It is right here. The infinity you were searching for in the cosmos is the very same infinity you are made of. Section 6. A world of pure potential. We have journeyed inward, through the teeming, vibrant universe of a single cell to the great, coiled library of a DNA molecule. We have found a vastness within that mirrors the vastness without. But this inward journey is not over. We must now take the next and most disorienting step down the ladder of scale. Let us zoom in on this 6-foot thread of DNA, past its elegant double helix structure, and focus on one of the individual atoms that forms its backbone. A single carbon atom. To your mind's eye, this atom might first appear as a familiar image, a tiny solar system, the one we all learned in school. In the center is a solid, stable nucleus, a dense cluster of protons and neutrons. And orbiting this nucleus like tiny planets are the electrons zipping around in neat, predictable paths. This is a comfortable mechanical model. It is a world we can understand, a machine we can visualize. It is also completely and beautifully wrong. As our impossibly powerful microscope zooms in further, this miniature solar system dissolves into a strange and ghostly fog. The electron is not a tiny solid ball orbiting a center. It is not a thing at all in any sense that our human yardstick can measure. The electron exists as a wave of probability, a shimmering cloud of pure potential. Imagine the atom not as a solar system, but as a musical instrument, a single resonant bell. The electron is not a marble rolling on the bell's surface. It is the humming note the bell produces when struck. The sound exists everywhere on the bell at once, a vibration, a standing wave of energy. It does not have a precise location. Simply is. So it is with the electron. Its existence is smeared out over a region of space we call an orbital. It is not at any single point. It is a smear of maybe, a cloud of perhaps, a haze of potential. The denser parts of this cloud are where the electron is more likely to be found, if you were to force it to show itself. The thinner parts are where it is less likely to be. But until you look, until you interact with it, it has no definite position. It exists in a state of pure, unresolved potential. And here we encounter the deepest weirdness of this inner realm. The very act of looking, of trying to measure the electron's position with our human yardstick, fundamentally changes it. The moment you try to pinpoint the electron to ask the universe, where are you right now? The cloud of possibility instantly collapses into a single definite point. The ghost is forced to appear. The wave of maybe becomes a single droplet of here. But in this act of forcing a choice, a sacred bargain is struck. The moment you know with certainty where the electron is, you have lost all knowledge of where it is going. Its motion, its momentum, becomes completely and infinitely uncertain. And conversely, if you were to measure its momentum perfectly, its position would dissolve back into an infinite smear of possibility. This is the Heisenberg uncertainty principle, a fundamental law of this inner world. It is the universe's gentle but firm insistence that some things are, by their very nature, unknowable. Our classical solid world of definite positions and predictable paths is an illusion, an approximation that works on our large scale, but dissolves into a beautiful probabilistic haze at the bottom. And this strangeness is not limited to the electrons. Let's push our microscope to its final limit and peer into the nucleus itself. Even here, the protons and neutrons are not solid little marbles, packed together like stones. They too are fuzzy quantum entities, their properties and positions governed by the same shimmering clouds of probability. The very floor of reality, the bedrock of matter, is not made of rock at all. It is made of mist. We have now traveled so far inwards that the very concept of scale has lost its meaning. How can you measure the size of a cloud? How can you use a yardstick on a wave of potential? Our journey has taken us from the world of things to the world of ideas, a world governed not by simple mechanics, but by the elegant and mysterious laws of quantum probability. We have reached a world made not of substance, but of shimmering pure potential. Section 7, the smallest possible thing. We are adrift now, in the shimmering probabilistic mist of the quantum realm. The solid ground of our familiar world has dissolved beneath us, and our human yardstick has become a useless artifact from a forgotten land. Here, in this world of pure potential, it seems we can zoom in forever, descending through endless layers of maybe and perhaps. It feels like an infinity of smallness, a bottomless ocean of the minuscule. But is it? Is there a floor to this abyss? Is there a point where we can go no smaller? A place where the very concepts of space and distance finally break down and cease to exist? This question brings us to one of the most profound and mind-bending ideas in all of modern physics. It is the concept of a fundamental, indivisible unit of space, a single smallest possible thing. It is a length so incomprehensibly small that it stands as the absolute final floor of reality. We call it the Planck length. To approach this idea, we must first understand the two great pillars upon which all of modern physics rests. The first is Einstein's theory of general relativity, the language of the very large. It is a theory of the smooth, curving, and continuous fabric of spacetime. It describes the graceful waltz of planets and galaxies, a world of beautiful flowing geometry. The second pillar is quantum mechanics, the language of the very small. It is a theory of the granular, the jittery, the probabilistic. It describes a world of discrete energy packets, of shimmering clouds of potential, a world where reality seems to be made of distinct, indivisible chunks. For a century, these two great theories have been our best descriptions of the universe. And for a century, they have refused to speak to each other. Relativity works perfectly for the large, and quantum mechanics works perfectly for the small. But when you try to combine them to describe a situation where you have immense gravity in a tiny space like the heart of a black hole or the first instant of the Big Bang, the mathematics breaks down into gibberish. The equations scream with nonsensical, infinite answers. The Planck length emerges from this grand clash of titans. It is the scale at which the smooth geometric world of Einstein and the jittery quantum world of Max Planck finally meet. It is the scale at which the force of gravity, usually so feeble on the small scale, becomes as strong as the other quantum forces. And at this point, our current understanding of physics suggests that spacetime itself ceases to be a smooth, continuous fabric. It becomes a foam. Imagine a beautiful silk tapestry. From a distance, it looks like a smooth, continuous surface. But as you zoom in, you begin to see the individual threads from which it is woven. Zoom in further, and you see the fibers within the threads. The Planck length is, in a sense, the ultimate fiber of spacetime. It is the fundamental, indivisible pixel from which reality is constructed. You cannot have a distance that is half a Planck length, any more than you can have half a pixel on a computer screen. It is the final, granular resolution of the universe. So how small is this ultimate pixel of reality? The number is so small it defies all metaphor and all intuition. A Planck length is 1.6 x 10 superscript 3 meters. This is just a string of symbols. Let's try to feel it. Let us return to our atom, a shimmering cloud of potential. If you were to take that single atom and expand it, magnify it in your mind until it was the size of the entire known universosphere billions of light-years across, then on that colossal new scale, a single Planck length would be about the height of an average tree. Let us try another way. The smallest thing your eye can see is about the width of a human hair. Imagine the journey of scale from the width of a human hair down to the size of a single proton in the nucleus of an atom. That is an immense, almost unimaginable leap of smallness. Now, take the journey of scale from the size of that single proton down to the Planck length. That second journey is as vast as the first journey from the human hair all the way up to the size of the entire observable universe. The Planck length is the limit. It is the point where our questions about what is smaller cease to have meaning. It is the floor of the inner universe. Below this scale, there is no below. There is no space, no time, no distance as we know it. There is just the fundamental churning quantum foam from which reality itself emerges. It is the ultimate boundary of our inward journey, a final, beautiful, and absolute end to the concept of smallness. Section 8. The Ladder of Infinities. We have journeyed outwards to the edge of the visible cosmos, and inwards to the absolute floor of physical reality, the Planck length. We have been stretched and compressed by scales so extreme they have shattered our intuition. And in both directions, we have brushed up against the ghostly, mesmerizing concept of infinity. A universe that may stretch on forever. A number like pi whose digits march on forever. And now, for our final exploration, we must leave the physical world behind entirely. Let us step into the purest, most abstract realm of all, the world of mathematics itself. For here, in this silent cathedral of pure thought, we will find the most mind-bending truth about infinity. We will find that infinity is not just one thing. Some infinities are bigger than others. Our guide on this final, dizzying leg of the journey is a 19th-century mathematician named George Cantor. He was a man who dared to do what no one had done before. He dared to treat infinity not as a vague, poetic concept, but as a number that could be measured, compared, and tamed. He began with the simple, beautiful idea. How do you know if two sets of things have the same number of items without counting them? Imagine a large hall filled with people and a large hall filled with chairs. How can you tell if there is a chair for every person? You don't need to count either. You simply ask everyone to sit down. If every person has a chair and every chair is filled, you know the two sets are the same size. You have created a perfect one-to-one correspondence. Cantor applied this simple, elegant logic to the infinite. He first looked at the set of all the counting numbers 1, 2, 3, 4, and so on forever. This is a classic baseline infinity. Let's call it the infinity of a staircase that goes up forever. Then he looked at a different set of numbers, the set of all the even numbers, 2, 4, 6, 8, and so on. At first glance, our intuition screams that there must be fewer even numbers than all numbers. Feels like there should be only half as many. But Cantor applied his simple test. Can we create a one-to-one correspondence? Can we give every counting number a unique even number partner? The answer is yes, and it is startlingly simple. For any counting number, just multiply it by 2. The number 1 gets partnered with 2. The number 2 gets partnered with 4. 3 gets 6. 100 gets 200. For every single number on our infinite staircase, there is a unique even number waiting for it. Every person has a chair, and every chair is filled. Therefore, Cantor concluded, the infinity of even numbers is the exact same size as the infinity of all counting numbers. It was a shocking, counterintuitive, but logically undeniable result. This first level of infinity, he called Aleph Naught. It is the infinity of things you can count, even if it takes forever. But Cantor did not stop there. He then turned his attention to a different, much denser kind of infinity, the infinity of all the numbers on the number line. Not just the whole numbers, but all the fractions in between them. And, most importantly, all the irrational numbers like pi and the square root of 2, the numbers with endless non-repeating decimal expansions. This is not the infinity of a staircase, but the infinity of a smooth, continuous, unbroken line. He asked the same question. Can we put these two infinities into a one-to-one correspondence? Can we assign a unique counting number to every single point on this infinite line? And here, with a proof of stunning beauty and ingenuity called the diagonal argument, Cantor showed that you cannot. It is fundamentally, logically impossible. No matter how you try to create a list that pairs the counting numbers with all the numbers on the line, he showed a simple, clever way to construct a new number that is guaranteed not to be on your list. The line is thicker, denser, more profoundly infinite than the staircase. The hall of points on the line contains infinitely more members than the hall of counting numbers. There are not enough chairs to go around. This was his greatest discovery. There is a ladder of infinities. There is the countable infinity of the staircase, Aleph Naught. And then there is the greater, uncountable infinity of the line. And he even showed that there were infinities greater still, an entire endless hierarchy of infinities, each one unimaginably vaster than the one before. This is a world that has no connection to our physical reality. It is a discovery made in the pure abstract realm of thought. And it is perhaps the ultimate lesson in the failure of our human yardstick. Our intuition, which failed us with the scale of the cosmos and the quantum foam, fails us even more profoundly here. It tells us that infinity is just a lot. But the quiet, patient logic of mathematics reveals a truth that is far stranger, far more beautiful, and far more vast than our minds could ever have invented on their own. It is a universe of infinities, a ladder of thought that ascends forever, beyond any hope of physical comprehension. Section 9. An echo of the savannah. We have traveled to the outer limits of the cosmos and the inner floor of reality. We have even climbed the rungs of an infinite ladder of infinities in the pure world of thought. And at every turn we have felt our minds stretch, strain, and ultimately fail to grasp the sheer, alien scale of it all. The numbers become too large, the distances too vast, the smallness too profound. We are left with a feeling of awe, but also a feeling of profound inadequacy. And this leads us to a final, more intimate question. Why? Why is this so hard? Why do our minds, these magnificent instruments of thought and reason, struggle so profoundly when faced with the true scale of reality? The answer, like so many truths, lies in our own story. It lies in our deep past, on the sun-drenched savannas of our evolutionary birth. Let us return there one last time. Imagine again our ancient human ancestor. Their world, as we have seen, was a world of the middle scale. Their life depended on a very specific set of perceptual skills. Their brain was not designed to be a universal, all-purpose reality comprehension machine. It was a specialized, bespoke survival kit, exquisitely tailored for a very particular environment. What did this survival kit need? It needed to be able to judge the distance to a gazelle, a distance of tens or hundreds of meters. It did not need to comprehend the distance to the moon. It needed to be able to differentiate between a pile of 5 stones and a pile of 10 stones. It did not need a concept for a billion. It needed to be able to track the passing of a few days, to anticipate the coming of the rainy season. It did not need to grasp the concept of a million years. The brain is a costly organ. It consumes a tremendous amount of energy. Evolution is a ruthlessly efficient accountant. It does not waste resources building capacities that are not needed for the immediate and pressing business of staying alive and having offspring. A brain that spent its precious energy contemplating the size of the galaxy or the nature of a quantum particle would have been a less effective brain for spotting a lion hiding in the tall grass. And so, evolution sculpted a mind that was a master of the terrestrial, a virtuoso of the immediate. Our intuition for numbers is a perfect example. It is logarithmic, not linear. The mental distance between the number 1 and the number 2 feels vast. But the mental distance between the number 101 and 102 feels tiny, almost non-existent. Our brain cares deeply about the difference between 1 apple and 2 apples, but it cares very little about the difference between 101 apples and 102. For survival, this makes perfect sense. And it is why we can intuitively grasp small numbers, but why a number like a billion or a trillion is just a word, a placeholder for a lot, with no felt reality behind it. Our intuition for space is the same. We live in a world that, for all practical purposes, obeys the simple flat geometry of Euclid. Straight lines appear to be straight. The angles of a triangle add up to 180 degrees. Our brains are hardwired with this Euclidean software because it works perfectly for navigating our local environment. And so, when we are told that on a cosmic scale space is curved, that parallel lines can meet, our deepest instincts rebel. It feels wrong, not because it is wrong, but because our software was never designed to run that kind of program. So, when we feel our minds breaking against the shoals of cosmic or quantum scale, we are not experiencing a personal failure. We are not bad at thinking big or small. We are simply feeling the ghost of our own evolutionary past. We are hearing a deep echo from the savannah. We are feeling the design limitations of a tool that was built for a very different purpose. And yet, here lies the true human miracle. The very fact that we can have this conversation, that we can even know that our intuition is failing, is astonishing. We have used the parts of our brain that evolved for one purpose: logic for tracking prey, pattern recognition for finding food, and we have repurposed them. We have bootstrapped our savannah mind into a cosmos mind. We have invented the language of mathematics, a formal system of logic that allows us to bypass our flawed intuition and follow a chain of reason into these alien realms. We cannot feel the size of the galaxy, but we can calculate it. We cannot visualize the quantum wave function, but we can write down the equation that describes it. Our ability to even glimpse these infinities is a testament to the remarkable, transcendent power of human thought. We are creatures of the mud who have somehow learned to contemplate the stars. We are the echo of the savannah, learning to sing a cosmic song. Section 10. The Home in the Mystery. Our long journey of scales is coming to its end. We have traveled outwards from the familiar comfort of our own skin to the silent, web-like tapestry of the cosmos, a structure so vast it renders our galaxy a single speck of dust. We have journeyed inwards past the teeming universe of a single cell, through the probabilistic mist of the quantum world, down to the absolute floor of reality, the indivisible pixel of spacetime we call the Planck length. We have even stepped beyond the physical, into the pure, abstract realm of thought, and found a ladder of infinities, each one vaster than the last. At every step we have felt our human yardstick, our innate and trusted intuition, splinter and dissolve. We have been confronted with the fabric of reality so alien in its scale, so far beyond the grasp of our savannah-forged minds, that we are left feeling untethered, adrift in a sea of concepts we can name but never truly know. It is easy at the end of such a journey to feel a sense of profound vertigo, a feeling of being hopelessly lost in the face of it all. But let us, in these final, quiet moments, embrace a different perspective. Let us reframe this feeling not as one of being lost, but as one of being found. What if the goal of this journey was never to truly comprehend infinity? What if our inability to do so is not a failure but a gift? A perfect comprehension of the universe, a mind that could hold the entirety of the cosmic web and the quantum foam in a single easy thought, would be a mind without wonder. A mind without mystery. It would be a mind without the thrill of the chase, the joy of a new discovery, the gasp of awe before a beautiful unsolved puzzle. Our limitations are what make the universe interesting. Our inability to see the whole picture is what drives us to keep looking. The truth is, you do not need to comprehend the universe to be a part of it. You do not need to hold the galaxy in your mind to be held by the galaxy. You are already home. You are not an outside observer, struggling to understand a foreign system. You are a piece of the system, a tiny, intricate, and beautiful part of the very fabric we have been exploring. The carbon atoms in your body were forged in the heart of a dying star that lived and died billions of years ago, a star that was part of the same Milky Way city we struggled to imagine. The water that flows through your cells is made of hydrogen forged in the first few minutes after the Big Bang, the beginning of the cosmic tapestry itself. The strange, probabilistic laws of the quantum realm are not just a curiosity. They are the very reason the sun can shine, the very reason the molecules in your body can hold together. And the human mind that struggles to grasp it all is the universe's own, unique way of becoming aware of its own grandeur. You are the cosmos made conscious. So let the struggle for comprehension fall away. Let the numbers and the scales dissolve. And in their place, let a quiet sense of belonging settle in. Feel the gentle gravitational pull of the earth beneath you, a tiny echo of the cosmic curvature we explored. Feel the warmth in your body, the product of the teeming, inner universe of your cells. Feel the gentle rhythm of your breathing, a simple, steady beat in a universe of mind-boggling scales. The mystery is not a wall between you and reality. The mystery is the reality. And you can find a peaceful, quiet home right in the center of it. You do not need to have the answers. You only need to be open to the beauty of the questions. As we conclude our journey, allow the vastness of these ideas to simply become a soft, dark blanket of wonder. The need to measure, to compare, to comprehend can be laid to rest. The universe, in all its infinite complexity, will continue its silent, majestic dance, whether we are watching or not. And you, a precious thinking part of it all, can now surrender to the gentle restorative scale of sleep. You are a part of the fabric, and you are safe within its folds. Sleep well and may your dreams be vast and peaceful. Good night.